The last thing we're going to look at is the vertical asymptotes. And we're going to look at the vertical asymptotes. Remember, a vertical asymptote and a horizontal asymptote are lines on the graph that the function will approach but never quite reach. Remember, the whole is just a skipped point, a single value. The asymptote is an entire line. So we're going to be looking at the asymptotes, but we're going to look at the vertical one. To find the vertical asymptote, we'll write this here. To find the vertical asymptote, this is where the denominator equals 0. However, one quick note, does not include wholes. No wholes. So if you find that something is a whole, it can't be an asymptote, vice versa. If it's an asymptote, it's not a whole. So we're going to go back to what we did earlier, and we're going to see what makes the denominator equal to 0 for each of these, and that's going to be our asymptote. So if we look at this one, let's see here. If we look at this one, what would make the denominator equal to 0 in number 1? X would be -2. If x is -2, I get -2 plus 2, which is 0 in the denominator. You can't divide by 0, so x equals -2. Now, the important thing to remember, okay, and let me use a different color so we don't get these all confused. X equals -2. Remember, you have to look at your wholes. If it's a whole, it can't be an asymptote. We don't have a whole, so x is -2 is okay. Look at number 2. What did we determine in the domain that x could not equal? X could not equal 6. Basically, whatever your domain cannot be, whatever's excluded from your domain, is going to show up in your wholes and your asymptotes. So all of these values are either going to be a whole or they're going to be an asymptote. That's why they don't work. So here, what would make x minus 6 equal 0? Well, 6. Okay? So there's no wholes here, so the asymptote is 6. On the next one, x minus 1 is your denominator. What would make x minus 1 equal 0? Well, 1. Check it against, do you have any wholes? Nope. So that is an asymptote. And this is the vertical asymptotes. This is the up and down asymptote. Okay? The horizontal asymptote is the sideways asymptote. Okay? All right, for this one, I know it's kind of hard to read because I messed it up. I'll rewrite it off to the side in the correct factored form. We have -2 times 2x plus 1 over -x plus 1. That's the correct factored form. So what would make -x plus 1 0? Well, -1. I'm sorry, positive 1. Positive 1. So x is equal to 1. So if x is 1, that's 0. Again, no wholes, no conflicts. All right, on this one, what are the two possibilities that we found the denominator couldn't be? It couldn't be 0 and it couldn't be -4. Do I have a whole at one of those places? Yes, I do. I have a whole at -4. So then -4 is a whole, so what's left over for the asymptote? 0. The asymptote cannot be the same as the whole. Since there's already a whole at -4, 0 is the asymptote. Let's look at the next one. -1 and 3 were the two values that didn't work. I have a whole at -1, which means the asymptote is at 3. Here, 2 and -1 did not work. Those are what would make the denominator 0. I have a whole at 2, so my asymptote is at -1. Here, -2 and 1 did not work. I have a whole at -2, which means my asymptote is at 1. And again, you can get that by looking at, you can't have a -2 or a 1 because those would make the denominator 0. And of those, -2 is a whole, so only 1 can be an asymptote. You have -3 and +2 were the two values that made this 0. -3 is a whole, so only x equals 2 is an asymptote. And then on the last one, you have -2 and 1. Those are the two values that made the denominator 0. You didn't have any holes, so that means you do have two asymptotes. You do have an asymptote at -2, and you do have an asymptote at 1. And that is how you find the vertical asymptotes.